An extension of abstract classes is interfaces. Interfaces provide a similar or are from a similar concept when we're dealing with abstract methods. One of the limitations of classes in Java is that you can only inherit from one class, or from a class that inherits from another class would be more than one. But you can only inherit from one class directly. But you may have multiple abstract classes. The diagram down below says we might have a shape class and we might have a math constants class that are separate. Java does allow for a construct that would allow us to inherit from these things so long as the methods are abstract and variables are constant. These are known as interfaces instead of classes. It's a way around this multiple inheritance problem. So I have two different types here. I have shape, which before, as we had seen, declares a function stub called area, which must be implemented by subclasses. So since circle extends shape, it must provide an area method. And then I have this other one called math constants, which declares this constant pi, which actually is already created for you, but I'm just using it as an example. Java does have a math constants interface already. The circle class can use the constant pi in math constants and it is forced to provide an area method by the shape interface. So how does this look? Well, we define this thing called shape, and instead of class, we're going to call it an interface. And this method is int area. Again, this is a function stub. Now, because it is an interface, this is automatically assumed to be an abstract method. It is only a function stub. So that means that anything that will use shape must therefore must provide for an area method. So you do not need to use the word abstract. It is implied for this int area. Double space var, special var is a variable, which is double, but this is implicitly declared as what's called final. Now there's a new keyword for you, final, which means that it cannot be changed. And a variable that cannot be changed is another word for a constant, and in this case 3.14. I would have labeled it pi, but I didn't want to reuse something that was already in something else, which is math constants. And I'll talk about the best practices for naming constants within Java. So here I have class circle, and this should be a lowercase c. Again, this is a PowerPoint issue. Implements shape. When I use an interface, I am implementing the interface. I am not extending the interface. So here I have my int area because I have to override the area method, and I return special var times radius as the example. Just a little note on the final keyword. The final keyword is used when you wish to make classes, methods, or variables immutable, non-changeable, or in a certain respect, non-changeable. The final class is a class that cannot be subclassed. It represents a final derivative of the class. Nothing else can be derived from it. So an example of that is the string class. You cannot extend string and create your own. A final method is a method that cannot be overridden by some classes. So I may have defined a method that is not allowable to be overridden by a child class. And that's done to ensure the integrity of the particular function or the method. And a final variable is a variable that cannot be changed. It is a constant. A good practice is to name your variables that are going to be constants in all uppercase so that you can delineate them from regular variables. So here is, and that is not mandatory. So here are two examples. I can create my class, example 1, and create final and use the keyword final in front of it. This class cannot be subclassed. So I am not allowed to extend example 1. Here's another class, example 2. And I have final double pi equals 3.14159. Within the class, I have declared this as final, which means this variable cannot be overridden. It is a constant. In the interfaces, all variables that are declared within an interfaces are implicitly final, so you do not need the keyword. We have another method here called test method within this example 2, which is also declared as final, and that says that any class that extends example 2 cannot override this test method, that this test method is as is. It is going to be consistent to what the original design was. Now I can use multiple interfaces, unlike classes where I can only extend one class. And that's simply done by implementing the multiple interfaces separated by commas. So if class circle implements shape, comma, math constants, comma, new interface 3, anything within shape math constants and new interfaces is available to this code. So any abstract methods or function stubs that are defined within these must be declared within here and provided a concrete method. And any variables or constants that are defined within them, within these interfaces, are also available to the circle class.